So in this unit called gas laws, here are the following objectives. First of all, we are going to need to understand and properly use the properties to describe gases. We should also recognize the units and variables for the gas properties. We are going to be able to convert temperatures from Celsius to Kelvin and from Kelvin to Celsius. And we're also going to perform calculations using the combined gas law and the ideal gas law. Now, so first off, the phases of matter that we talked about are solids, liquids, and gases. Solids have a definite volume and a definite shape. And here's a little molecular model. Liquids, they also have a definite volume, but they don't have a definite shape. They take the shape of your container, much like the liquid here in Joey's water bottle.
Damn right, my water bottle.
And gases have no definite volume and no definite shape. Gases expand to fit their entire container. So that old idiom, the glass is half full or half empty, is not true, because it's always full. No matter how much liquid's in there, it's full of liquid and gas. Now,
in this room, right now, are millions of gas molecules and atoms colliding with the walls, the floor, your face, and each other. Can you feel it? When do we notice this?
Now, so guys, when do we notice gas? When do we notice the gas particles? When do we feel that? When? Yes. When do we feel that? How about yesterday afternoon? It was a little bit windy out. Do you notice the gas particles then? No. No? Really? I do, because you can feel them. You can feel them hitting you. You can feel them in differences in pressure. Snow is a solid. But if you notice when the gas particles are moving, you can definitely feel that. Or has anybody gone up in an airplane and noticed that their ears pop?
Yeah. Or if you go over a hill too.
Or if you go over a hill. Yeah, in a car. You notice those that change in pressure.
Why does gum help you pop your ears?
I think because your ears can equalize pressure. The question was, Diamond, the question was, why does gum help that? And that's because you have these special tubes that connect your inner ear to your throat, and that helps equalize the pressure. That's why. Any other evidence of gas particles collisions? You know, what if I sprayed some perfume up here? What would happen? It would spread around the room. Eventually, first Kimmy would smell it, then Cohen, Diamond, and Joey, and eventually it'd get all around the room. Yeah, well, it depends on the airflow, but assuming there's not much airflow, eventually everybody in the room's going to get a scent of it. So in these next couple of slides, we're going to discuss how we talk about the properties of gases. First one is volume. Now, the variable that represents volume is V. That's a stretch, I know. And it just represents how much space the gas occupies. The units of volume that we use are liters, milliliters, meters cubed, and centimeters cubed. You probably talked about those units in your geometry class. The next property of gas we're going to discuss is pressure. Now, pressure is the amount of force exerted by the particles that collide with each other and their surroundings. Units of pressure that we're going to use in this class are atmospheres. The abbreviation for atmospheres is ATM. Kilopascals, which the unit is kPa, in millimeters of mercury. Now, millimeters of mercury is just how much how high the gas pressure can force up mercury in a tube. So that's that's one of the first units of pressure that was used. One. The next property we're going to discuss is temperature. Now, temperature really measures the average kinetic energy of particles. What that means, kinetic energy, anyone know what kinetic energy measures? Marcus. The energy associated with movement. So, yeah, so it's essentially how fast particles are moving. So if you're at a high temperature, your particles are moving faster on average as if they were at a low temperature. The units of temperature that we are going to use are called Kelvin. We only use Kelvin temperature in gas laws. Always. That's the type of temperature we use. What temperature do we use in gas laws, Colin? What temperature? We always use what? Kelvin. Good work, Kyle. So that's when we use, that's the only temperature we use. And the conversion factor is easy. All we have to do to calculate temperature Kelvin is take the temperature Celsius and add 273. So, Nigel, what would 0 degrees Celsius be in Kelvin? Well, how would you calculate that? How would you calculate if the temperature Celsius was 0? Yeah, so what would 0 plus 273 be? Yeah, so 0 Celsius is equal to 273 Kelvin. What would negative 273 Celsius be in Kelvin? Marcus? Good. 0. So negative 273 degrees Celsius is 0 Kelvin. That's called absolute zero. And that's when particles stop moving. They have so little energy that they don't move anymore. Yes, Kimmy? Oh, no, that's 0 Celsius. That's negative 273 Kelvin. Yep. So the last property is one that we're going to be reviewing here, and that's moles. Now, the variable that we're going to use for moles is the letter N, because that's the number of particles. It just measures how many particles there are. And the abbreviation for moles is mole, M-O-L, not M. M is meters, not to be confused with moles. So the unit for moles is M-O-L. And we all know that that is just a measurement of how many particles there are. So if I have more particles, I have more moles. And we did a whole unit on that, which we will be reviewing soon. So the first law we're going to learn is the combined gas law. And this is used to predict how, if we change one property or multiple properties, the other factors change. And the law is P1 times V1 over N1 times T1. Those are our initial conditions. Equals P2 times V2 over N2 times T2. So that's the relationship. A key thing is about this equation, when a variable isn't mentioned, we're going to assume it's constant and we're going to remove it from the equation. So the variables represented, P is pressure, V is volume, N is number of moles, and T is temperature Kelvin. So here's an example, and why don't you guys try this right now? Go through the problem. Write the problem down. And make sure, what I want you guys to do is fill in all the variables. So, for instance, when you see a sample of a gas occupies 200 milliliters, what do milliliters measure?
Damn it.